Okay, so this is a fairly standard sort of question. Well, not standard, it's quite common though. The examiners like this type of question where you have to work out how many moles of crystallized water you have in a hydrated salt, like so. And the experiment is heating to constant mass. Heating to constant mass. That's when you heat it to get rid of all the crystallized water, and then you weigh it, and you keep on doing so until the mass is constant. And when it's constant, you've got rid of all of the water. But in this case, they've only heated it once. All right, so I suspect that in a subsequent question to 3.1, they're going to ask us about that. But in any case, let's do 3.1 first. So we've got the mass of the empty evaporating basin, and then solid before heating. So that's with the water, crystallized water. This one is with the crystallized water. And supposedly this is the one without the crystallized water. Although, as I just said, I suspect that it's not. And they're going to ask us about that in a subsequent question. Okay, so let's see. What we have to do is work out the value of x. Now, before we plunge in and start calculating stuff, let's make a little plan. And what we realize to start with is if we look at the difference between these two, you're going to have the mass of the that's going to be the mass of the hydrated solid. So let's call that mass hydrated. And if you look at the difference between these two, that's going to give you the mass of the dehydrated solid. We're going to assume it's dehydrated for the purpose of this little part of the question. Okay, so if we had the mass of the dehydrated solid, we've got the formula of the dehydrated solid. That's just that bit. So from which we can work out the MR of that. So if we have the mass and the MR, we work out the moles. Now, if we had the moles of the dehydrated solid, then that's going to be the same as the moles of the hydrated solid. So if we had the mass of the hydrated solid and the moles of the hydrated solid, we'd be able to work out the MR of the hydrated solid, from which we'd be able to get X. All right. So let's go through that process. Let's do it on the left-hand side here. Okay, so we're going to say mass. Let's say, let's call it mass hydrated. So the mass of the hydrated is going to be 25.47. Take 24.35. And that is 1.12 grams. And in the same way, we might as well work out the mass of the dehydrated. So mass dehydrated is 24.92. Take away the 24.35, and that comes out to be 0.57. Okay, so we've got those two masses, and according to our plan, we need the MR of the dehydrated. If we have the mass of we can't get the MR of the hydrated, the ones with the water, because we don't know what X is, but we can get the MR of the dehydrated one because we got that formula. So the MR of the dehydrated, all right, equals, from the formula, we've got 2 times 23 is 46. We've got 12, and we've got 3 16s is 48. So I'll make that 106. So that's 106 grams per mole. like so. So now we've got the MR, right? And so if we've got the MR there, 106, and we've got up here, we've got the mass of the dehydrated one. So we work out the moles. Okay, so moles of dehydrated. Moles of dehydrated. So moles equals mass over MR. Mass is 0.57. And the MR we just worked out 106. And so that comes out at 5.377 times 10 to the minus 3. Okay, now, as we said before, the moles of one has got to be the same as the moles of the other. Okay, so let's write that down. Moles of hydrated. Moles of hydrated equals the same. 5.377 times 10 to the minus 3. And we know the mass, so we can work out the MR of the hydrated. MR of hydrated. MR of hydrated. So I have to just write out this moles equals mass over MR. So MR is mass over moles. Mass was 1.12. And moles is there, 5.377 times 10 to the minus 3. And that comes out at 208. Let's write it here because we're running out of space a little bit. 208.3 as it happens. So if we think of 1 mole of this whole hydrated stuff, so in 1 mole, comma, there is how much water? Well, there would be 208 is the mass of the whole lot, and 106 is the mass of the sodium carbonate. So that leaves 102 grams of water. 102 grams of water. Okay, so how many moles is that? 102 grams of water. All right, and that will give you X, right? So X is the number of moles of water that we have in 102. So water, MR of water, just the H2O bit, is 16 plus 2 is 18. All right, so we're going to do 102 over 18. 102 over 18, and that comes out to be 5.67. 5.67. So, and it wants our answer to 2 decimal places. So there you have it there. 5.67. And you would expect a whole number because you can't have a fraction of a water molecule. All right. So I suspect that the next part of the question is something to do with why is it not either a whole number or why is it not more, a bigger number than 5.67, and the answer is going to be that it wasn't heated to constant mass, and so you didn't drive off all the water, and to drive off all the water you need to heat it again and keep heating it until you get constant mass. All right, so that answers these 5 marks and probably a few of the next marks as well. I hope that's helped.